Welcome to the Robot Millennium 2D frame analysis movie. There are many ways of inputting data inside Robot Millennium, either through tabular format, cutting and pasting through programs such as Excel, or input from third-party products such as other well-known structural analysis solutions, or DXF, DWG, or many other different types of file type. In addition to these methods, there is also the ability to define data on a predefined grid, or to make your own grid, which we term a structural axis. Here we are making a simple 2D grid that we can later input data on graphically inside Robot. A grid now appears on the screen that enables us to draw structural members and structural entities onto the grid. We can now choose a type of member that we're going to use, in this case a concrete column, and to define a start and end point graphically. Now for some steel members. In this case from the British section database, although many other section databases are available in the software. We're now also going to define a tapered steel member. And back again to some steel members for the rafters. Now for some support definition. There are many different types of support type that you can apply inside Robot. Advanced types of support allow us to define tension-only, compression-only supports, and also non-linear supports. Now for defining some load cases, and inside these load cases we're going to define some individual loads. Starting off in this case with some dead load, and we're adding on some simple point loads into the dead load case, and of course some member loads along the member. In this case 1/3 of the way along each member. Note in Robot how it's only necessary to indicate the end of the member that you wish to consider as the origin, and the program will take care of everything else. Now for some extra loading. This time we're going to add some UDL loading. And this loading is going to represent some wind loading. And finally some snow loading. Of course, we can now proceed to combine these loads into preset combinations, or in fact use the codified combinations inside Robot. We can now press the calculations button to solve the structure, and of course look at the results in some detail. Firstly, we're going to look at the diagrams for the beams. In this case, shear force, major axis bending, and when we are happy that we have a picture that we like, we can make a picture of that, which we term a screen capture, which can later be used to formulate a printout, as we will see later. If we just want some quick information about one member, we're able to make use of the Object Properties command, which shows us everything about that member, section sizes, forces, displacements, for any load case. There is also a simple code checking facility inside the Object Properties command. Of course, in addition to graphical results, there are also tabular results. Here is a typical table inside Robot. And should we wish, we can filter these results to get exactly the kind of result that we require. And when we have seen what we wish to, we can make another screen capture of this table. So to now formulate those screen captures and standard data into a printout. Here we have a list of screen captures, and we can add those to the printout composition. We can now preview this composition, of course change the title blocks, the paper size, and we can see exactly what we have on the screen. We can then take that and transfer it into a Word document should we wish.